Today we're going to look at two lessons. The next two we cover in Chapter 7. You may notice we skip over 7.2. We'll come back to that next, but 7.3 and 7.4 kind of go along with what we were looking at before, just our properties of exponents. So go ahead in your table of contents, put the date next to those sections, and then whatever page you're on over here in your notes. All right, so here are our two properties for, first we're going to look at 7.3, multiplication. These are our two multiplication properties. Let's talk about how these are different. The first one, you can see if you're multiplying two of the same base. So we have this base of A and this base of A. So if you're multiplying the same base, what you do is you take your two exponents and you just add them together. So for example, let's say you had 5 to the third times 5 to the second. What you could do is say, hey, look at that. We are multiplying 5s. Your base is 5. So when you multiply the same base, it's basically this exponent property is a shortcut. You would say, let me keep my base of 5, and then you just take your two exponents, the 3 and the 2, and you add those together, and you get 5 to the 5th power. So if you were to look at this kind of written out in the long way, 5 to the 3rd power is 5 times 5 times 5 times 5 squared. So that's 5 to the 3rd power. Now 5 squared is 5 times 5. And then if you look at what you have, basically you're multiplying a bunch of 5s together. Well, how many 5s are you multiplying? If you count them up, 5. So this exponent property that has us add our exponents is a great shortcut to that. The next property that we have, this one, if you notice, you don't have your two bases of the two of the same base. What you have this time is one base, a set of parentheses. Parentheses might be a good heads up on this, and two exponents. So this is called I think it's called the power of a power exponent property. So you have a to the m power, and we're taking this and we're raising it to another power. So what you do is instead of adding your exponents, so if you have your one base and you have the power raised to a power, you just take those two exponents and you multiply them together. That is multiplication in between there. So for example, what that means is, let's say you had 2 to the 3rd power and we wanted to raise that to the 2nd power. Our property tells us to keep the 2, keep the base, and then multiply our exponents. Multiply the 3 times the 2. 3 times 2 is 6, and you get 2 to the 6th power. This property is also a shortcut. If you were to look at this the long way, 2 to the 3rd power squared means 2 to the 3rd power times itself, 2 to the 3rd power. Well, this 2 to the 3rd power means multiply 3 2's, so there's the first 2 to the 3rd power. This 2 to the 3rd power means multiply 3 of them. So there's 2 to the 3rd power times 2 to the 3rd power. Again, multiplying just a bunch of 2's, and you get 2, how many of them? 6, 2 to the 6th power. So we really like our exponent properties because they are shortcuts to kind of writing it out the long way. So let's look at some examples of these, and what you'll notice is your properties all get kind of mixed together and we simplify them, and a lot of times there's more than one way to simplify it, and we'll just always try to find the easiest way through the problem. So this is your basic, that first property where we're multiplying a 5 times a 5, so it's the same base. Now you don't actually multiply 5 times 5 to get 25, you keep your base of 5, and you take your two exponents, and should we add or multiply them? We're going to add those. So 4 plus 2 is 5 to the 6th power. Now if you want to go ahead on your calculators and say what 5 to the 6th power is, that's fine. If the exponents are too high, a lot of times we will just leave them, like if it said 5 to the 12th power, we would just leave it as 5 to the 12th power. But let's see, 5 to the 6th power is, well, that's kind of a big number, but we can still write it down. 15,625. All right, moving to the right, we have x cubed to the negative 6 power. So you see your one base of x right here, and you've got your power raised to a power. So you're going to keep your base of x, and then the exponent property tells us that we can multiply those together. 3 times negative 6 is negative 18. Now here's the thing, is we cannot leave an answer with a negative exponent. It's kind of like having a fraction and not reducing it all the way. So if you do your math and you see that you have an x to the negative 18th power, you have to say, well, I can't leave it as a negative 18. So think back to what we did in 7.1. We learned a property that told us if you have a negative exponent, you have to move it. We're going to move it down to the bottom because it's in the top. Nothing left on top, so it's going to be 1 over, and then that exponent becomes positive, x to the 18th. And then that is as simplified as we can get that. Oh, look at this. More examples. How nice. So the problems in this chapter, they'll be short and sweet, but you might have more of them to do because we're not, solving a system of equations. So the nice part is that even if it looks like a lot of problems, they won't take as long. So when we simplify this, I would go ahead and let's get this one simplified, and then we'll multiply it by m squared because you have kind of the set of parentheses to take care of. So m squared to the 3rd power, that's that power to the power. We're going to multiply that and get m to the 6th power, carry down the rest of the problem times m squared, and now you've got that first property where you're multiplying the same base, so you keep your m, and then those exponents, you add them. 6 plus 2 is 8. Positive exponent, so we're okay. M to the positive 8 power. All right, so our next example, we actually have, let me kind of show you kind of the long way to write it out, but it's the way that kind of explains how it works. You have 2d to the 4th power, or 2d squared raised to the 4th power. So this 4th power has to go to everything on the inside. It's going to go to the 2, and it's going to go to the d. So the way that this would get written out is you would say, well, here's my base of 2 to the 4th power. Here's my d, although it's a d squared, to the 4th power. And then you simplify just one at a time. So 2 to the 4th power is 2 times 2 times 2 times 2, which is 16. It's a little sloppy. Oh, good, I can erase it. So it's 16. And then d squared to the 4th power, that's our exponent property. You keep the d and multiply your exponents and get 8. So what you want to be able to do is recognize when do you multiply your exponents, when do you add your exponents. The only time you're going to add your exponents is if you see, like in this example, 2 of the same bases separated with a multiplication. You multiply the exponents, you're going to have that set of parentheses when it's a power raised to a power. All right, last 2 on this slide. Of course, we have more slides to go, but that's okay. Everything in here gets squared. So we're going to square the 3, square the c, and square the d. Again, the long way to write this out is going to look like this. And I'm going to write this out so we're not confused on what we're doing. So all I'm doing is I'm taking each piece inside the parentheses and squaring it. And then you just go left to right and simplify one at a time. So 3 squared is 9. C squared squared, so there's that power to a power. You multiply those and you get c to the 4th power. And then d to the 4th squared, we're going to multiply that and get d to the 8th. It's a weird looking 8, but you guys know what it is. There's our final answer. All right, next example. You have n to the 4th squared. So what are you going to do with those? Hopefully you're saying multiply in your head. You are correct. Times. Now here's m to the negative 4 to the negative 2. There's that power to a power again. And you have m. Now negative 4 times negative 2. I see negative exponents, but when you multiply those, you actually get a positive 8, which is very nice. So our final answer is n to the 8th, m to the 8th. Or, if you remember, how do you write, if you have more than one variable in a term like this, it actually would be alphabetical, so it would be m to the 8th, n to the 8th, but for right now, I would take either one, just to show that you're doing the math correctly. All right, so our division properties for exponents. Again, this video is probably feeling a little long because we are covering 2 lessons in one, so just bear with me. If you are, this first property, if you are dividing the same base, then all you have to do is subtract your exponents. So, for example, if you have x to the 3rd power over x to the 2nd power, that's, you keep your x and you subtract, it's always the top minus the bottom, so 3 minus 2, which is 1, or x to the 1st power. So if you're dividing your same base, you subtract your exponents. And then this last property just tells you that whatever you are dividing on the inside of a set of parentheses, that exponent would go to every base on the inside. So let's say you have 3/4 and you want to square it. You would square the 3 and you would square the 4, so it would be 3 squared over 4 squared. 3 squared is 9, 4 squared is 16, can't reduce it, so that would be your answer. All right, this is the last slide, although I'm guessing we have some, oh, yep, look at that. All right, so let's run through these. First example, pretty straightforward. You're dividing your x's, so keep your x, and then 6 minus 2 is 4, and you get x to the 4th power. All right, the next one has a little bit trickier because you've got that 12 over the 3. Now, if you have those coefficients out front, you actually do want to divide those. 12 divided by 3 is 4. And then, if you're dividing bases that have exponents, you keep your x and you subtract the exponent. So 10 minus 6 is 4, and you get 4x to the 4th power. Good so far? Feeling good? All right, next one has a little bit of work to do before we deal with this overall division right here. If you notice, we've got parentheses raised to the 3rd power, so we're going to have to bring that in on the top and bottom. So on the top, and this is, we can kind of do this in our heads a little bit. So 4 to the 3rd power, 4 times 4 is 16, 16 times 4 is 64. And then m to the 5th power to the 3rd power, multiply those and get m to the 15th power. Over. Now on the bottom, you square the 8 and you get 64. Oh, that's kind of nice. And then you square the m, but it already has an exponent, so you keep your m and you just multiply those. Now when we simplify this, divide the numbers out front first. 64 divided by 64 is 1, or you could just cross them off. And now the m's, when you're dividing your m's, you keep your base of m and subtract. 15 minus 6 is 9, so we get m to the 9th power. All right, now we've got this big set of parentheses over here. What I would say to do here is let's simplify inside and then square everything. So first thing I notice is this a to the 0 power. Do you remember what anything raised to the 0 power equals? That is just a 1. And 1 times a cubed is a cubed. So really we're looking at 3a over a to the 3rd power. This whole thing is squared. We can go ahead and simplify in here because we're dividing the same a's. So inside our parentheses, you have your 3. Oh, maybe I don't want that line yet. Sorry, you have your 3, because there's nothing to divide it by in the bottom. A divided by a cubed. So you keep your base of a, and you subtract your exponents. So that's a to the 1st. 1 minus 3 is negative 2. And then we can go ahead and raise that to this. Oh, thought I was going to sneeze. Didn't happen. Excuse me. All right, so now we have to square everything in here. So square the 3, and you get 9. Square the a to the negative 2, so that's one of those where we multiply a to the negative 4. So how do you feel about that as a final answer? Well, it looks pretty good, except for the fact that you have this negative exponent. that has to move down to the bottom. Sometimes these feel like never-ending problems. When that goes down to the bottom, your 9 stays on top. That's a 9. And a to the negative 4 becomes a to the positive 4. And that's our simplified answer. Whew. All right, last two. This one, I would simplify everything inside your parentheses first. So x cubed over x cubed, go ahead and cross those off because anything divided by itself is 1. Now you got y cubed over y squared. So you keep your base of y, subtract your exponents. 3 minus 2 is 1. This whole thing is being raised to the negative 4 power. So again, you would multiply your exponents. You get y to the negative 4, which is equal to, bring it down to the bottom, 1 over y to the positive 4 power. That one's done. All right, this last one, a little bit tricky, I think. Let's see how this works. First, let's simplify up here. We're going to bring that in there, so we're going to multiply. You're going to have a, this is what this was tricky, blah, blah, blah. Okay. So, do you see this negative d squared? There actually is a number in front of your d squared, and that is a negative 1. So you have to bring the 4th power into the negative 1. So it's a negative 1 to the 4th power. And you also have to bring it into the d. So you're going to have d to the 8th because you're multiplying your exponents. Over. Now this negative is out front, so you just have that negative 1 is outside of your parentheses, so that's just going to stay as a negative 1 down here. And then you bring your 4th power into your d, so you're going to have d to the 8th. Now when you simplify this, first I might notice the d to the 8th over the d to the 8th. Anything divided by itself equals 1. So let's see what's going on with these negative 1s. Negative 1 to the 4th power, if you multiply 4 negative 1s, you actually end up with a positive 1. And then in the bottom, we just have a negative 1. And then what's 1 divided by negative 1? Negative 1. Whew, all right. Done with that intro video.